Welcome to PhyzQuest. So this is the solution video for CSIR NET December 2019 Part C, question number 15. The question is, a particle hops randomly from a site to its nearest neighbor in each step on a square lattice of unit lattice constant. The probability of hopping to the positive x direction is 0.3, to the negative x direction is 0.2, to the positive y direction is 0.2 and to the negative y direction is 0.3. If a particle starts from the origin, the mean position after n steps is what we need to calculate. So let's get started. So this question comes from the section Statistical Mechanics, and the concept involved here is random walk. So first of all, the concept of random walk is a sequence of discrete fixed length steps in random direction. Now random walk can be one-dimensional, two-dimensional or three-dimensional. In the given question, we are dealing with a two-dimensional case of random walk. Here we have a square lattice with lattice constant 1. Now the square lattice is in xy plane. So any object in random walk in this situation, in this two dimension, will have 4 possibilities. What are those 4 possibilities? That is, it can have the possible direction for a particle to move in a two-dimensional random walk will be either it can move in positive x direction or negative x direction, or positive y direction or negative y direction. So these are the 4 possibilities that a particle can move in a two-dimensional lattice. Now the probability of the 4 possible movement of the particle along the possible direction are given as: for positive x direction the probability is 0.3, for negative x direction the probability is 0.2, for positive y direction the probability is 0.2, and for negative y direction the probability is 0.3. So these are the probabilities. Now initially the particle is at origin. So first of all we will calculate what will happen when the particle takes a single step. That means what would be its next position after taking a single step. So now here remember that here the position means I am talking about the mean position, that is after considering the probability along all the 4 directions. So the particle has a probability of moving positive x direction is 0.3 and negative x direction is 0.2. Since negative x direction has a lesser probability, the particle will move towards the positive x direction overall, and its movement along x direction will be 0.3 minus 0.2 I cap. Now this is not complete a single step. The single step means we have to consider all the direction. We have just talked about the x direction. Now the probability along positive y direction is 0.2 and negative y direction is 0.3. So here the overall probability along the y axis is negative. So here along y axis, if you consider, the movement of the particle will be plus 0.2 minus 0.3 j cap. So now after this the particle has reached this point, and ultimately upon calculation this will be 0.1 I cap minus 0.1 j cap, which is equal to 0.1 I cap minus j cap. So this is the indicating the position of the particle after a single step. Now the question is, we need to calculate what would be the mean position after taking the n number of steps. Now n, we don't know exactly the value, but n steps. So it would be simply, you just have to multiply n with this number, that is n into 0.1 I cap minus j cap, which is equal to n by 10 I cap minus j cap. So this is your answer. Now there is another method which you can proceed. There is a direct formula which you can by using which you can calculate the mean position of the particle for random walk. So instead of doing this, you can use a direct formula. So the formula for the mean position is given as Ri, which indicates the mean position, which is equal to summation over Pi Ri. So here Pi indicates the probability associated with that position along that axis. So using this formula, what we can do is Ri is the distance covered in that direction, in that particular direction, and Pi is the probability associated with that distance or with that axis, along that axis. So we just have to put the respective probability value along with the distance covered in that direction. So it will be equal to, so as I said, in the positive x direction, the particle, see, overall if you put, is a two-dimensional lattice, so it has four possibilities, that is positive x, positive y, negative y. So we will consider the distance along those direction along with their probability and put it in the formula, so it can give you the same answer. So let's see that. So it will be Pi/Ri. So for positive x direction, the probability is 0.3 and the distance is 1, because that's the lattice constant is 1. So this is equal to 0.3 into 1 into I cap. So then for negative x-axis, it is, the probability is 0.2 into 1 into I cap, minus sign because it is a negative x-axis. So again for positive y-axis, it is 0.2 into 1 into j cap, because we are considering y-axis. So this is for positive y-axis. Again, then for negative y-axis, this is minus 0.3 into 1 into j cap. So ultimately when you finally calculate it, this will be 0.1 I cap minus 0.1 j cap, which is equal to 0.1 I cap minus j cap. Again, we need to calculate for n number of steps. So for n steps, the mean position is equal to, simple, you have to just multiply n with it, which is n into 0.1 I cap minus j cap, which is equal to n by 10 I cap minus j cap. So you can see whatever we have discussed earlier, it's giving the same answer. We have just put it in the formula, in the direct formula. So now let's check the options. Now you can see, if you check the option, you can see that option B is matching with our result. So correct answer for this question is option B.